Hello, welcome to the next video on our recitation problem solving series. And in this video, we are going to be looking at how to plot some graphs by applying basic transformation by using some basic graphs. In here, I put these graphs together as a revision of some of the basics graph that we have. And whenever you have to plot a graph, you don't have to plot the points, like getting the points of x and then evaluating the function and tracing these points on your graph. To make a simple sketch, you can always start with a basic graph and then apply some rules of transformation, and from there you will have your desired graph. So let's dive right into it. So the first question is here, 51. Okay, it says in the following problems, start with a basic graph and then apply some transformation to obtain the appropriate graph. Okay, so let's do that. 51, we have to plot the graph of y equals to minus square root of 1 plus x over 2. So if you look here, our independent variable x is under a square root. Okay, and if we look at our graph, the more appropriate graph to use here is the graph of y equals to square root of x, which is shown here. So this right here is the graph of y equals to square root of x. So the graph of y equals to square root of x divided by 2 is the same graph, only a little bit stretched down the x-axis. So we can plot it something like this. So let's say this is our coordinate system. Then we have something like this. Sorry. Okay, one more try. Okay, so let's say this is our graph of y equals to square root of x over 2. Okay, so now we need to add 1 to it, right? So if you remember, if you add 1 inside the square root, is exactly moving this graph to 1 unit to the left, right? So because 1 here is positive, so you remember when the addition on is in your function argument and is positive, it goes to the right, and if it is negative, it goes to the left when it is positive, and it goes to the right when it is negative. So this is like taking this graph and moving it 1 unit on the x-axis. So let's complete this. Okay, so let's say this is -1 right here. Okay, and then now this graph is the graph of y x squared plus 1. Okay, so the next thing we have to do is take care of this negative here. So this is nothing but a reflection. Okay, so all we have to do is reflect that graph across the x-axis. Okay, so let's plot it in blue here. Okay, now we don't need this, we can delete this. Okay, so what we have here, this blue line is our graph of y equals to minus square root of x over 2 plus 1. Okay, so let's put some points here. So if we extend this, and also let me change this to black to match. Okay, so this is y, this is our x-axis, and this point here is -1. Okay, so let's call this 1, 2, 3, 2, 3. So, and we don't need this as well. Okay, so this is the graph of y equals to minus square root of x over 2 plus 1. Okay, don't forget this is under square root. Okay, next we should plot the graph of y equals to 1 minus x over 3. Okay, so we have 52. Plot the graph of y equals to 1 minus x divided by 3. Okay, now in here we can start with a basic graph of y equals to x over 3 and then negative. So if, okay, let's plot some graph. Okay. So let's say this is our graph of y equals to x divided by 3. And then if we add a negative, we are going to reflect this graph like this. Okay, so this is graph of y equals to minus x over 3. Now we can delete this because we don't need this. Okay, and then we have plus 1. So this plus 1 moves the graph 1 unit in the y-axis because we have an addition of constant 1 and it's positive, so it moves up in 1 unit. So this is going to be something like this. Okay, actually it should be more of something like this, and we can delete this. We don't need this anymore. Okay, so now this is 1 here, and let's say this is 1, 2, and then we have 3 on the intersection, because you can see when y is 0, okay, x will be equals to 3. You can check it from here. If you substitute y equals to 0, then you have 1 minus x over 3. If you take it to the other side, so you have x over 3 equals to 1. So x is equals to 3 when y is equals to 0. Okay, so that's why you have this point right here. And we have y equals to 1 when x is equals to 0. Yes, so this right here is our graph of y equals to 1 minus x divided by 3. Okay, we can delete this if we wish. Okay, the next graph is the graph of y equals to 1 over 2x squared plus 1. Okay, so we have the graph of y equals to 1 over 2x squared plus 1, I think. Yes, okay. So we can draw this graph by taking the basic graph of y equals to x squared. So you can see it from the first page. This right here is the graph of y equals to 1 over x squared. Okay, so if we plot this, okay, let's straighten this a little bit. Okay, Okay, so okay, so let's say this is our graph of y equals to 1 over 2x squared, and now plus 1, we just need to take this graph 1 unit above. Okay, so let's move this above, let's say 1 unit. Okay, okay, and then we can draw this hypothetical line of y equals to okay. So this straight line is the line of y equals to 1. Okay, because this is 1, 2, and 3 right here. Okay, so this is the graph of y equals to 1 over 2x squared plus 1. So we started with a basic graph of y equals to 1 over 2x squared. And because we have this addition of 1, then we move it 1 unit above in the y-axis. Okay, so the last and the final graph is the graph of y equals to minus cube root of minus cube root of 5x. Okay, so that's to be 54. Okay, so this is 53. Okay, 54. We have the graph of y equals to minus 5x to the power of 1 over 3. Okay, so this is the same thing as square root of minus, so cube root minus 5x. Okay, if we use this notation. So you can see from here, our basic graph should be a cubic graph, which is this, right? So we should take this as our basic graph. Okay, so let's sketch it. Okay, so let's say this is graph of y equals to cube 5x. Okay, and now if we put a negative inside, then this is going to reflect this graph across the y-axis. Okay, so we will have something like this. Yeah, sometimes it's difficult to get it to predict the shape you are trying to draw. Okay. Yeah, sorry, this is actually a reflection across the x-axis, not the y-axis, but it could also be perceived as because of the symmetry. You can also see it as a reflection across the y-axis as well. So this black is the graph of y equals to minus cube root, cube root of minus 5x, which is equals to minus 5x to the power of 1 over 3. And this one is equals to the positive 5x. Okay, so this is how you plot this simple graphs. Okay, let's see. Okay, now the next part of the problem is okay, let's add the page here. Okay, so we need to solve for the even and odd functions. We need to determine if these functions are even or odd. Okay, let's see if I can just copy this and paste it in the next so that I don't have to keep scrolling. Okay, so the first one, y equals to x squared plus 1. Okay, well, this is an even function because the x is squared. So if, for example, we take x equals to 2 and x equals to minus 2, so in both cases, y is going to be 2 squared plus 1, which is 5. Y is equals to minus 2 squared plus 1, which is 5. Okay, so this is an even function. Okay. Number 10, we have y equals to x 5 minus x cubed minus x. Okay, so because the power here, we all have the power of this polynomial raised to an odd integer. Okay, so this is an odd function. Okay, if you wish, you can check it. For example, you can select some values of x. For example, x equals to 1 and minus 1, and you can see that this will be an odd function. So we don't have to do that here. You can just see based on just by looking at the powers, we can see that this is an odd function. Okay, 11. We have y equals to 1 minus cos x. Okay, so if you remember, for the cosine function, cos x is equals to cos minus x. Okay, so cos is an even function, and hence this 1 minus cos x is also even function. Okay, so this is okay. The next one, 12. We have y equals to sec x tan x. Okay, So this is going to be y equals to, so sec x is the same thing as 1 over cos x times sin x over cos x. So this is the same thing as sin x divided by cos squared x. Okay, so for the denominator, this is we know that cos squared of x is equals to cos squared of minus x. Okay, and we know that minus sine x is equals to sine minus x. Okay, so because of this last statement here, then we can see that this should be an odd function, because sine of negative x over, okay, cos squared of negative x is equals to minus sine x over cos squared of x. Okay, so this is an odd function. Okay, so let's stop here, and in the next video we can solve the remaining problem.